My name is Abdul Haleem and you are watching my YouTube channel. So today we are going to start another video regarding calculation of empirical formula as well as molecular formula. So we already discussed about the empirical formula as well as molecular formula. Empirical formula is the ratio of atom that is present in a molecule. Just like we have an example, glucose. So glucose is composed of 6 carbon atom, 12 hydrogen atom and 6 oxygen atom. So this is also one of the most important example. And so if we take the ratio of this molecule, so it will be equal to CH2O. So now we can calculate the empirical formula, because empirical formula is an experimental formula. So we have to perform different experiment for the preparation of, for the analysis of the compound, after analysis and determination of mass and detection of the elements. So after that we can make calculation, and then we can calculate the empirical formula. So let's go and calculate the empirical formula. So we have a couple of examples. So let's take one example here and also other example of molecular formula. Actually, molecular formula is actual number of atoms that are present in a molecule. So what we have to do, we have to find out the empirical formula first, then we will calculate the molecular formula, and after that, so we will first we have to calculate the empirical formula, then we have to calculate the n, and n is the integer number, and it can be found from by dividing the mass with the mass of molecular mass of that compound with the mass of empirical formula. So then we will obtain n. Now if we multiply this n with the empirical formula, then we will obtain the molecular formula. So this is all about the empirical as well as molecular formula. So we can calculate the molecular formula, and we can take different examples, and let's see how we can do it. So in this video, ethylene glycol is used as automobile. So there is a problem of empirical formula. Ethylene glycol is used as antifreeze in automobile, and it has a 38.7% carbon. So we have to make a data like this data. So in data, carbon is 38.7% and hydrogen is 9.7% and oxygen is 51.6%. So there are 4 or 5 steps of empirical formula. The first step, detection of elements that already given, and also the masses of each element. So and third step is the percentage of each element. So percentage is already given. Now we have to find out the empirical formula. So the fourth step is to calculate the mole ratio. So for mole ratio, what we have to do, we have to divide the percentage with the atomic masses of that element. Okay, so now we have mole ratio of carbon. So carbon, the percentage of carbon is 38.7 percentage divided by atomic mass of carbon, that is 12. And what about the hydrogen? Mole ratio of hydrogen, and that is equal to 9.7, that is percentage divided by 1 is atomic mass of hydrogen. And oxygen, the mole ratio, so mole ratio of oxygen is same way, the percentage is 51.6 and divided by atomic mass of oxygen, that is 16. Now the percentage 12 divided by 38.7 divided by 7 means the value of we have to calculate, for example 38.7 3 times, that is equal to 2.7, and this the value is lower, so what we have to do, we remove points and give point on this decimal. So now that is 27, so 12 2 times, and that is 3, again 3 is less than 12, so what we have to do, we give 0 2 0 3 like this, and so the answer of this will be equal to 3.20, and this value 9.7 divided by 1, that is 9.7, and 51.6 divided by 16, this is also the value, so we have to divide 51.6 divided by 16 3 times, 3, there is a point, so and then 6, so we have to give a point here, and also we have taken 6 here. Now there is 36, and also we have given point here, and now we have to divide this 16 36, that is equal to 32 means 4 means 2 times, and that is also equal to like 3.2. So now this is the mole ratio. Now we have to calculate the simplest ratio. So simplest ratio, this is carbon, hydrogen and oxygen. The carbon is 3.20, hydrogen is 9.7 and oxygen is 3.2. So the minimum value is 3.2, so we have to divide 3.2 and 3.2. So this is 1 and this is I think 3 times, this is also 1. So the empirical formula, therefore empirical formula will be equal to, therefore empirical formula is equal to CH H3O. So this is the empirical formula of ethylene glucose. Now we want to calculate the molecular formula. So how we can calculate the molecular formula? So we can take an example like this. So if we divide the molecular formula, for example, molecular formula is equal to, we can write above, like molecular formula. We can find molecular formula is equal to empirical formula into N, and N is molecular formula mass divided by empirical formula mass. So molecular formula mass, that is 62, that was already given, and empirical formula mass, that is equal to like this: CH3O 12 plus 1 into 3 plus 16, this is 19 into 12, that is equal to 31. So 31 divided by 62, that is 2. So we have to multiply this by 2. So the molecular formula will be is equal to empirical formula CH3O into 2. This will be equal to C2H6O2. So this is the empirical formula of the molecular formula of the ethylene glycol. Thank you very much for watching my video. If you like my video, then you subscribe my channel and share with other friends. Thank you very much.